Hello. Okay. So hello everyone. Thank you for coming. This is type level visible type application, and my name is Nguyen from Bryn Mawr College. And I admit this is my first talk ever. So if I do something, I don't know, just bear with me. Thank you. Okay. So first of all, what is visible type application? So visible type application is a language extension that was implemented by my professor and advisor, Richard Eisenberg, about 2 years ago. But what it is, okay, so let's see. Oops, do I move too fast? Okay, never mind. Okay, sorry, I knew I would mess up, okay. Okay, so let's look at these two very familiar functions. So we have show and read, and that's the type signature of those. And so it's pretty easy to understand, and so you would expect something like this to work, because why not? But then it doesn't. This is what I got from GSCI when I typed that in. So what's the problem here? So the problem is show and read are polymorphic functions, and inside GSC, under the hood, they have to really know what the A is in here, and they have to check that against the term that is passed into the function in order for this to work. And so you can do it with type annotations, but in many cases it wouldn't work. So what's the solution for this? This is where visible type application comes into play. So if you want the A to be int, you just add in, and that's it. This is what is returned. If you want it to be double, that's also possible. So really, what visible type application is it's that it allows user to explicitly declare the type arguments to polymorphic functions. And the syntax is really easy. It just add followed by the type arguments to be instantiated, and it helps resolve ambiguity and produce very elegant and type-safe programs. So we're thinking, how about type level? So kinds are just basically types of types. So if you have visible type application, why can't you have visible kind application, which is type level visible type application, as I like to say. So this has led to a GSC proposal, number 15. I have linked to this if you want, but I won't go into details here. But anyways, that's the proposal that I was implementing. So to formalize it, visible type kind application is the specification of kind arguments in kind and higher-kinded polymorphic cases. And extend the benefits of term level visible type application to type level. So you have all the safety and the versatility of visible type application, you have the convenience, and you have more correct type information. So let's look through an example. And this is actually not my example. It's originally by Iceland Jack on one of the GSC track tickets. And it uses the category theory for Haskell by Edward Kmet. So it's going to be in kind in Hask. That's a category theory for Haskell. Okay, so let's look at these two things. So I have a data type mu with that type signature over there. You don't really know what it does. You don't even need to know what it does. Just look at the type signature of it. It's k to type to k to type to k to type. And we have a data type fun that is from k to type. And so we have a class functor, just like a normal type class functor for this. But so this is from a morphism f from I to j, where the type of domain of f is I to type, and type of codomain f, it's j to type. And there should be an f map function over there, but just for this presentation I didn't put it there. So now we say we want to write a functor instant for mu. Mu is the one over there. How do we do it? So since this is polymorphic, we want to clarify the kind to be in there. And this is how you do it without visible kind application. Yeah, so my choice of color, it's pretty bad, I think. But like, this is worse than my choice of color anyway, so I don't care. Anyways, this is really bad, and I can't even check whether I'm correct in this. Like, there's no way I'm gonna look through that and check. So this is what it's like with visible kind application. You can basically just pass in the K in there and everything else just figure out itself, because you only need the K, you don't need anything else. Why would you need that whole long thing with just a bunch of repeated things? And you can easily type check this against the kind of mu, which is K-type to K-type to K-type, and that's the I, and that's the J. You can kind of match yourself. I can't go back a slide to show you easily, but that's it. And I have some more examples. So the first example there was when I used the add sign for kind with kind variable, but here you can just easily use it with just any kind, and in this case it's a type. You have this data type TFA, and if you just want a type alias to work on only when the K is type, you can just do this. It also works on type families. It works well with scope type variables, and it works in GSCI, so it can give you more information on types and terms and stuff if you do the colon K. But for the interest of time, I will not go through that here. So this is how I implemented it in GSC. So my work was mostly with the parser. Oops. I don't know. With the parser, renamer, and type checker. And this is what I did in the parser. Basically, I added a new parsing rule to allow the typing of add before a type or kind argument. And there's actually a pretty subtle distinction between the add of type application and the type of as in like if you want to give something a name. I implemented that, and then in the renamer, it just processes just like a normal thing, so there's not much to talk about. But there in the type checker, so the main part of my work was in the type checker, trying to implement this. And the thing about type checker is it tracks the visibility of one argument, of the kind arguments, whether it's required, specified, or inferred. So what do these mean? So required, a required argument is one that is required to be supplied at every call site. So like the K in here, you can't just say X without the K. You need it there. A specified one is one that can be omitted, but can also be explicitly declared if you want. So like the K in the second example of data X. That K, you can just not just have X without it, but you can also explicitly declare that without extension. And finally, we have inferred, which is not explicitly written, but it's inferable by GSC. So why do I care about this? I care about it because I only want visual type application to work with specified arguments. If it's already required and you have to supply it anyway, I don't need it. And if it's already inferable by GSC, if it's more monocided, I also don't need it. So this makes sure that, no. Wait, what? Where can I go back? So sorry. I'm like messing up thing. Okay, yeah. So it makes sure that the feature is only used when it's needed. And so if you have something like maybe type, it will be rejected because simply maybe the kind signature maybe is type to type, so it's already figured out by the GSC. It's monokinded. Okay. So how do I implement that again? So to type check the visible kind application, the argument that visible kind application provided, I apply that to the function, and then I check the next argument. So I figured this would be better if I have an example. So say I have an example of data T, whose type is for K1 and K2. It's K1 to K2 to type, where mux T is TAB. And I have two data bool, which is true or false, or nat, which is 0 and subnat. And say I have this written out. How do I type check it? How do I make sure that my visible kind application is working as I want it to? So let's look through the process. So here, if you have the kind of, check the kind of T, it will be K1 to K2 to type. Oh, it should be fall as well, I forgot to put it in. And if I apply the bool, the type checker will check that, oh, there's a K1 in here that needs to be filled in, and I have supplied the bool in there, so it will check that, and it substitute the K1 to bool, like the type signature has shown in the right-hand side. If I want to do NAT, it will say, oh, there's another type, K2, that hasn't been specified, so I have NAT in there, and it's substitute that into K2. And now if I supplement false, it will go and check, oh, false is actually indeed of kind bool, so that's only a NAT to type. Now it's supply with 0, it's a complete type. Yeah, everything is type checked and all. So that's all. And I want to go through some design choices. So by the same, I don't know. So we want to keep this as close to the term level visible type applications as possible. And so it's by the same extension type applications. And the syntax is the same as you have seen in earlier example. It's a @ sign preceded by white space and followed immediately by the kind that you want to be instantiated. And we also have partial type signatures enabled by default. And that allows users to do things like data T for all K1, K2 to type, where mark T is TAB, is the same one. But now you can just not care about this one over here. If you just want to type check and apply the kind of the next one, that will work, and that will not generate any warning or error for you. It will not have any constraint on you. So you can just easily do that, and the GSC will figure out that false later is like a kind bool, and that N over there is going to be a kind NAT. So it's really doable. And I want to talk about some of the challenges. So in order to automatically enable partial type signatures for visible kind application, I had to use several language extension switches. Basically, I switch, oh, this is where partial type signatures are used, and this is where it's not. During type checking, I would like to fix it if I have some time, but I also don't know of any alternative right now, so I just leave it to that. Another thing is I refactored the handling of unnamed wildcards. So originally it was renamed. In the renamer, it was given fresh variable names in the renamer. But now that's not done anymore. The work is now deferred to the type checker, and instead of generating any name, it's actually generating some wildcard type variable and check that again. And I also implemented the work in templates Haskell. So now if you want to use visible kind application in templates Haskell, you can use the syntax app kind T, just like how you use app T normally in templates Haskell. But now in order to do this, it requires that user write the full type in type equations left-hand side. So originally in templates Haskell, you only need to write the arguments on the left-hand side without having to say the the type family's name. But we feel that one, it wasn't very close to the Haskell AST, and two, it can cause a lot of error if you just just mismatch some of the names. So it wouldn't figure it out. So anyway, it's now required that you have to write the full type in each type equations left-hand side on type families and stuff. So in the this is very near future, I'm trying to work on this fall. So we would like to implement visible type application in patterns, and this is actually. There's more information on this from the type variables in patterns talk that will be on Haskell Symposium on Friday. So if you're interested, just go, and you see that there's a lot of, a lot of things. Okay, so So I want to talk a little bit more about contributing for GSC for the first time. So I am an undergraduate student, and to be honest, I haven't had a lot of experience with Haskell prior to this at all. And so like the thought of working in GSC kind of scared me a little bit because I barely knew any Haskell, let alone working in GSC. But it was great because the community is so nice. Like I don't know Ben's here, but when I was trying to install GSC on my computer, I had some problem, and I just emailed him, and he's like helped me immediately, which is great. And then I have Richard Eisenberg, my advisor, always helping me, and the whole community. Whenever I ask anything, everyone's just so nice. So my point is, if I can do it, why can't you? So just do it. If anyone is still, I don't know, hesitant about like GSC, just go for it. Like I can do it. Yeah. So that was it for type level visible type application. And thank you so much for listening. I can take questions.
Questions, please. This is maybe a silly question, but so you had in your slides, and you mentioned you were matching on a visible type application in a pattern, in a type pattern, in a type family. Like,
Yeah.
Did that just work, or was there additional? You didn't mention anything needed to happen to make that work. Did
Like
that
type
work?
families?
Yeah.
Oh yeah, I need to work on that as well.
Okay, yeah.
Yeah, of course, yeah.
Yeah.
But I figured it's like kind of by extension of this talk, and I only want to focus on the main work in the type data and stuff. Yeah,
Okay.
but yeah, of course the
Yeah.
work in there as well.
Is this, I didn't see this in the release notes for 8.6. Is this planning on making it to 8.8?
Yeah, so
Okay.
the thing is I kind of finished it in July, and then
Okay.
I had a summer vacation in August. And as a college student, I just forgot about all my work during August.
Got it.
And then school, and then it's still there. Maybe next week I will submit it. And yeah, it's just really like personal for me. Like yeah, but
Gotcha.
it should be soon. Yeah, very soon.
Rejecting allocation from all kind of type, is this a deliberate decision, or is there a deeper reason for it that one has to do it that way?
Yeah, because if it's monokinded, the kind is already figured out by GSC. So
Yeah, but it might be confusing. For example, if you have a long out kind of allocation on a type, and some are more, sometimes are more kind.
yeah, I guess it's for users. It's easier if you have that. But I was thinking about maybe for GSC, like that's kind of because the way that polymorphic functions are handled under the hood of GSC is that it's kind of just there's like an invisible type application always going on there, and so it's already in there. If you supply another argument, and if we process it the same way as we do with what I'm doing right now, it will be a false thing because GSC has already generated that extra kind or type argument to be instantiated within it. It's just not clear in polymorphic functions, like polykinded things. But in monokinded, it's just there already. So if you supply and if you do it, and I guess it's more a user feature, but if you do it the way that we're doing right now, that would be false because it will not accept that at all.
But now I have to essentially count which are the kind variables. So otherwise I would just kind of see in what position it occurs.
Oh, you can apply it at any position. Like so in for example in some of these
For example, in this example.
yes. So for example, right. So you have K1 and K2 here.
Yeah. Yeah,
so
K1 would be
right.
fine.
So what I did was that I put the the useful kind application first. But if you don't want to do that, you can also do bool first, and then you pass in false first, and then later you pass in nat. It could also work that way. So in fact, so what I mean to say, this is in order, but you don't have to always do it in order like this. You can, because this bool is applied to false, you can also say false here, and then add nat later, and then do it. But for something like, so for what you asked later, well, I'm sorry, not later, but for what you asked earlier, yeah, you asked whether this should work in many other cases, right? It won't because it has for polymorphism is kind of handled in that the GSE will try to find the kind or type, and it basically generates, it's not visible, but it generates an extra argument. So the word that it was I made it visible. But in this case, the invisible doctor is the thing invisible is already figured out by GSE. So if I supply this thing, it will be wrong. Just making the type something it's not. Does that make sense? Yeah. So yeah, I wish I could type something out here to illustrate that, but I think I can show you after the topic if you want. Yeah.
Would it maybe also make sense to be able to pass kind parameter not by position but by name? So I want to say, oh, this kind that I quantified the
Yeah, I mean, I haven't thought about that. I guess it's not, yeah, it's not by position, like you just pass it, but maybe, I don't know if that's ideal to do that.
If I wanted to give K2, then I would be able to write K2
Right.
equals something.
Yeah, I guess if you want to do that, you kind of just have to remember it, like the example on, no, where was that?
That's a type level record. No.
Or like you have partial type signatures. I guess you have partial type signature. If you don't want to do it for K1, where was that? Huh, that's bizarre. Oh, maybe it's after this. Oh yeah. So this is it for K2. I guess if you don't want to do it for K1 and just want straight to K2, you just leave a wildcard. That's the current solution. Yeah.
Okay, I also have one question about the last point you brought up. You said everything, like you said all the things that are great about contributing to GHG and being a first time.
Yeah.
What is the thing that is the worst?
Like, I'm sorry?
What is the thing that is the worst for you as a first time contributor to GHG that we maybe could fix or should work on? Like give us something
Right.
to
Yeah, right. So I think on the GSC developer website, there's like a lot of track tickets, and I think it's divided by bugs and feature requests and just several categories of those. So if you're interested in fixing bugs, I think just grab one of those and just claim the bug as yours. So if you want to do that, just do that, and then submit it for review. And there's a whole committee to, I guess, review or any changes that you make. So it should be fairly straightforward. And there's guides on the GSE website as well.
Okay, but what I meant is like, how can we make that even better for contributors like you? Like,
I see.
What is the thing you struggle the most with, or the most the most unpleasant thing about the procedure?
I guess it's just the first time I looked at the whole GSC compiler inside, like there's a lot of code and like they're so complicated and like I never saw anything like that before. So I guess that was it. But like I don't think that can be changed, right? It's the code base that is the most confusing. Like that can't really be changed. So
It starts with in features. That's
yeah.
Okay, well, thanks a lot for the talk.
Thank you.